Let us consider one more problem to solve using the GOMORY'S cutting plane algorithm. So this is the problem. Max z is equal to 7x1 plus 9x2 subjected to the constraints minus x1 plus 3x2 is less than or equal to 6. 7x1 plus x2 is less than or equal to 35. x1 and x2 should be greater than or equal to 0 and are integers. So now what we have to do? First thing is we have to convert this into the canonical form or the standard form. So this becomes minus x1 plus 3x2 plus slack variable s1 is equal to 6. Then 7x1 plus x2 plus slack variable equal to 35. Then we have to include this slack variable in our objective function. Max z is equal to 7x1 plus 9x2 plus the coefficient of a slack variable as 0, 0 into s1 plus 0 into s2. So these are our standard forms. Now you have to solve this using the simplex method. So write the simplex method table BV, CB, XB, X1, X2, S1, S2 and minimum ratio. BV, CB, XB, X1, X2, S1, S2 minimum ratio. Now this represents Cj. The coefficient of these variables in our objective function is x1 coefficient is 7, 9, 0, 0 and the basic variables are s1, s2. Now, the coefficient of this s1 and s2 in the objective function is 0, 0 and from the first equation this becomes the RHS 6 and here it is 35 minus 1, 3, 1, 0, 7, 1, 0, 1. Now, find out Zj value which is nothing but the summation of Cb into Xj where J represents 1 and 2. Now this into this plus this into this. For the first iteration all these Zj values will be 0, 0, 0 because we have here Cb is equal to 0. Then you have to find out Zj minus Cj. So this becomes Zj minus Cj. So minus 7, minus 9, 0, 0. So what is our next task? You have to find out the most negative number. So the most negative number will be this and this is our corresponding the entering variable column. To find out the leaving variable, your xb divided by value in the entering column. 6 divided by 3 gives you 2. 35 divided by 1 gives you 35. Yeah. Which is the minimum among this? Minimum among this is this one. So consider this as a leaving variable and this represents the pivot. So next second iteration. Now we have to, this is our new row and here this is the entering variable. This is the leaving variable. So you have to write x2 here and here s2. What is the coefficient of x2 in your objective function? 9. s2 is 0. And you have to find out this new row values. What is the new row value? Old value divided by pivot. 6 by 3 gives you 2. This is minus 1 by 3. 3 by 3 is 1. This is 1 by 3. 0 divided by 3. Next. find out the values for this, old value minus new value into value in the entering column. So 35 minus 2 into 1. So this gives you 33. Next, 7 into minus 1 by 3. 7 in minus 1 by 3 into 1. So you will get here 22 by 3. Then you will get 0 here, minus 1 by 3 here, 1. Find out the ZJ value. This into this. 9 into minus 1 by 3 gives you minus 3. Then here 9. Then here 3. Here 0. ZJ minus CJ will be this minus of minus this. So you will get here minus 10. And here 9 minus 9 is 0. 3 minus 0 is 3. 0 minus 0 is 0. So this is our new table now. Now again you have to find out here ZJ value is still it is not up to the optimality condition. So what is optimality condition? Optimality condition is ZJ minus CJ is greater than or equal to 0. But still we have a negative number here. So this we will be considering as a entering variable. To find out the leaving variable, the xb divided by this. So xb divided by this, since it is a negative number, we won't be considering this. 33 divided by 22 by 3, you will get 9 by 2. Among this, the minimum is 9 by 2. So this will be considering as a leaving variable where exactly it coincides. This is called as pivot values. So third iteration. So here this is our new row, and here to find out the values for the new row, the old value divided by the pivot value. So you will get here 7, 9 by 2, 1, 0, minus 1 by 22, 3 by 22. To find out the value for this, old value minus new value into value in the entering column. So you will get here 9, 7 by 2, 0, 1, 7 by 22, 1 by 22. What is ZJ? This into this plus this into this. You will get here 7, 9, and here you will get 28 by 11, 15 by 11. What is ZJ minus CJ? 7 minus 7, 0, 9 minus 9, 0, 28 by 11 and 15 by 11. All the ZJ minus CJ values are here. What is optimality condition? ZJ minus CJ should be greater than or equal to 0 and XP should not contain any negative values. So since it has reached to the optimal, it has satisfied the optimality condition, we will be stopping the iteration here. Now, what is the final answer? X1 is equal to 9 by 2. X2 is equal to 7 by 2. ZJ is equal to 9 into 7 by 2 plus 7 into 9 by 2. So, 9 into 7 by 2 plus 7 into 9 by 2. You will get here 63. These are the values. Now what is the problem here? We need x1 and x2 should be integers. Both are not integers. It is a fraction. So we have to cut to the fraction part of this answer by using the GOMORY cut plane algorithm. Both are fractions here. To select whether to select x1 or x2 to generate the GOMORY constraint, let us rewrite this answer as integer plus fraction. So I will represent this as integer of x1 plus fraction of x1. Integer of x2 plus fraction of x2. So 9 by 2. 9 by 2 I can write this as 4 plus 1 by 2. Okay, and here x2 is 7 by 2. So 7 by 2 I can write as 3 plus 1 by 2. 7. Now, to determine whether to select x1 or x2, you have to use the formula max of f of x1 plus f of x2. So here max of f of x1 is half, f of x2 is half. Both are equal. So there is a tie here. In this case, either you can select x1 or x2, or else to reduce the complexity you can use one more formula wherein you have to now find out f of x1 dash, f of x2 dash. What is this dash indicates? F of x1 divided by the fractional part of s1 plus s2. Here f of x2 dash is equal to f of x2 divided by fractional part of s1 and s2 in this table. Now, what is f of x1? F of x1 is equal to half divided by fractional part of x1. x1 is here. The s1 value here is, for x1, s1 is equal to minus 1 by 22, s2 is equal to 3 by 22. For x2, s1 value is equal to 7 by 22, s2 is equal to 1 by 22. So here again you have to write this as integer plus fraction, integer plus fraction. Here this is the integer plus fraction. This how we can write as integer plus fraction, since it is minus, we can write this as minus 1, so 22, so 21 divided by 22, 21 divided by 22. Now use the formula. Fraction part of f of x1 is 1 by 2. Fractional part of for x1, the s1 is equal to 21 divided by 22 plus for s2 3 by 22. This gives you 1 by 2 divided by 22 by 24. So this is 2 ones are 2 11s. So 11 divided by 24. 11 divided by 24. Consider this. This is equal to 1 by 2 divided by fractional part for x2 s1, 7 divided by 22 plus 1 divided by 22. So this becomes 1 by 2 into 22 divided by 8. This gives you 11. So 11 divided by 8. Now again same formula. F maximum of f of x1 dash comma f of x2 dash. So maximum of 11 divided by 24 comma 11 divided by 8. So which is the maximum here? The maximum is x2. So select x2. So select x2 row to generate the GOMORY constraints. Let us see how to generate the GOMORY constraint by using this x2 row. So write the expression 0 into x1 plus 1 into x2 plus 7 by 22 into s1 plus 1 by 22 into S2 equal to, what is the solution? 7 by 2. Now, how will you reduce this one? Again, you have to represent this as a fraction plus integer plus fraction. So 0 is nothing but 0. Here this is 0 plus 1 into x2, 0 plus 7 into 22 s1 plus 0 into 1 by 22 s2 equal to, how will you represent this? 3 6, so 1 by 2. Again consider only the fractional part. So this becomes 7 divided by 22 s1 plus 1 divided by 22 s2 equal to 1 by 2. As we know, always this will be greater than or equal. So what we have to do? We have to convert this into less than or equal by multiplying minus 1 to both RHS and LHS. Minus 22 S1 less than or equal to minus half. Now minus 1 by 22 into S1 minus 1 by 22 into S2 plus GOMORY constraint G1 is equal to minus half. This is our now GOMORY constraints. Put this GOMORY constraints expression in the last table. So the equation, the variable is G1 here, the variable will be G1 and its coefficient is 0. The RHS of the coefficient of G1 will be 0 and XB value will be minus 1 by 2 and X1 is not there, so 0, X2 is not there, 0, S1 is minus 1 by 22, S2 is minus 1 by 22 and the coefficient of G1 is G1, 1, so 0, 0. Now find out Zj minus Cj. Zj minus Cj will be same as the previous table, Zj minus Cj. You will get 7, 9, 28 by 11, 15 by 11, 0, 0, 0, 28 by 11, 15 by 11, 0. Now, the optimality condition is Zj minus Cj should be greater than or equal to 0. In our case, yes, Zj minus Cj is greater than or equal to 0. But if we observe here the XB column should also be greater than or equal to 0. But we have a negative number here. So, we have to consider directly this as a leaving variable. And now, we have to solve this using the dual simplex method. To find out which is the entering variable, use the formula theta is equal to Zj minus Cj divided by value in the leaving variable. So minimum among this will be the leaving variable. Find out the theta value now. So since it is a 0 here, you can just write as hyphen, hyphen, hyphen. So you have to find out the value for this. Zj minus Cj value is 28 by 11 divided by value in the entering column 22 by 7. So this becomes around 8 and here next here 15 by 11 into 22 by 1, so this becomes 30. Minimum among these two is S1, so this will be considering as the entering variable and this is called as pivot. So here it is a 7, it's a 7 here, it is 7 here. So 7 by 22. So our pivot value will also be minus 7 by 22. In the next iteration, S1 is the entering variable, G1 is the leaving variable. So to find out the values here, the old value divided by pivot, and these two rows here, old value minus new value into value in the entering column. So use the formula and find out all the entries here. You will get 9, 3, 0, 1, 0, 0, 1. 7, 32 by 7, 1, 0, 0, 1 by 7, minus 1 by 7. 0, 11 by 7, 0, 0, 1, 1 by 7, minus 22 by 7. Find out Zj value. You will get 7, 9, 0, 1, 8. Find out Zj minus Cj value. You will get 0, 0, 0, 1, 8. Now, if you observe here, optimality condition is Zj minus Cj is greater than or equal to 0. Correct? So, we got here Zj minus Cj is greater than or equal to 0, and all the xb values are greater than or equal to 0. Both the conditions are satisfied here. So, can we stop here? What is our x1 value? X1 value, if you take, it will be 32 by 7. X2 value will be 3. Z value will be 9 into 3 plus 11 into 32 by 7 plus 0 into 11 by 7. So, you will get your 59. These will be the answer. But what do we need actually here? We need integers. We doesn't need here fractions. So again you have to use GOMORY'S algorithm to remove this fraction from x1. There is no confusion of x2 you have got integer. But x1 value is fraction. That is why again you use GOMORY'S algorithm to cut the fraction part of this x1 and to get to the integers. Since x1 is fraction here, we will use the x1 row values to generate the GOMORY'S constraints. So 1 into x1 plus 0 into x2 plus 0 into s1 plus 1 by 7 into s2 minus 1 by 7 into g1 equal to 32 by 7. So again you just represent this as integer plus fraction. So you will get 0 plus 1 into x1. This becomes 0, this becomes 0. 0 plus 1 by 7 into s2 plus 1. How will you represent minus 1 by 7? So this becomes minus 1 plus 6 by 7 G1. Okay, minus 7 plus 6, you will get minus 1. 32, how will you represent the 32 by 7? 4, 4 by 7. 28, 28 plus 4, 32. Now consider only the fractional part. This will be 1 plus 0. So 0 into x1, anyhow you will get a 0. 1 plus 7 s2 plus 6 by 7 g1 equal to 4 by 7. Now usually this will be greater than or equal. So you have to convert this into less than or equal. Minus 1 by 7 into s2 minus 6 by 7 into g1 is less than or equal to minus 4 by 7. Minus 1 by 7 into s2 minus 6 by 7 into g1 plus here the new GOMORY'S constraint g2 equal to minus 4 by 7. Now you have to include this equation in our last the including of this equation here, we will not change your Zj and Zj minus Cj values. So I'll just write here the Gomori constraint to this one. This will be our Zj values. So this is Zj. This will be our Zj minus Cj values. So I'll just write here 0, 0, 0, 1, 8. This will be 7, 9, 0, 1, 8. Here Gomori constraint 2 and its coefficient is 0. And this is your Gomori constraint. So Gomori constraint coefficient is 0 and your solution is minus 4 by 7. Now x1 is not there in this equation, so this becomes 0 for Gomori constraint 2. x2 is not there, so 0. s1 is not there, 0. s2 is there, so minus 1 by 7. And g1 will be minus 6 by 7 g1. g2 will be 1. So rest all g2 will be 0. Now if you find out here Zj for the only for the last column, this into this, this into this, this into this, anyhow you will get here 0 and you will get here 0. Now what you have to check, Zj minus Ej is greater than or equal to 0. Yes, it is greater than or equal to 0. Oh, but what about our xb values? Xb value we have a here negative number. So we have a negative number. So consider this as a leaving variable, which is entering variable here. So you have to use the formula. So to use the formula, theta is equal to minimum of Zj minus Cj divided by value in the leading variable. Zj minus Cj is 0, so nothing, we won't get theta value, hyphen, here also hyphen, here also hyphen, here also hyphen. Only we have to find out the theta value for this S2 row and we have to find out for G1 row. So Zj minus Cj value is 1 divided by value in the leaving variable in minus 1 into 7. So you will get here minus 7. So we won't be considering any signs here. This will be like 7. Then here 8 divided by, so your value is minus 6 into 7. So you will get here (28 by 3). This is almost equal to 9 point something value. So here you will get 7, here you will get 9. So which is minimum among this? So S2. S2 will be considering as a entering variable. And where exactly it coincides, this is called as our pivot value. For the previous table, this is S1 and this is G2. Okay. Now S2 is entering variable and this is a leaving variable. How will you find out the values here? Old value divided by the pivot value. How will you find out the values for x2, x1 and s1? Old value minus new value into value in the entering column. This is how you will find out the values. Find out all the values and I will be writing directly the answer here. 9 you will get 7, 0, 0. 3, 4, 1, 4. 0, 1, 1. Do 0, 1, 0, minus 4, 1. So 4, 0, 0, 0, 1, 6, minus 7. This is what the answer you will get after using the two formulas. Now what is the next task? You have to find out Zj value. Zj value is equal to 9 into 0 plus 7 into 1. So we will get here 7. 9 into 1 plus this into this plus this into this, you will get 9 here. 0 into 0. So again here 0. And 1 into 0, you will get 0. 9 into 1 plus 7 into minus 1 plus these are zeros. So you will get 9 minus 7. So you will get 2 here. This is 0. So we have to consider this. Here these two are 0. 7 into 1 is 7. Now Zj minus Cj. 7 minus 7 is 0. 9 minus 9 is 0 minus 0 is 0. 0. 2. 7. So now whether your all Zj minus Cj values are greater than or equal to 0? Yes, all are 0. Whether your xb values here are greater than or equal to 0? Yes. Then it indicates we have to stop the iterations. Now note down all the values of x1 is equal to here 4, x2 is equal to 3, S1 is equal to 1, S2 is equal to 4, Z is equal to 9 into 3 plus 7 into 4. So 9 into 3 plus 7 into 4, you will get 55. These are the values. X1 is equal to 4, X2 is equal to 3, S1 and S2 is not required, but no need to write, but S1 is equal to 1, S2 is equal to 4, Z value is equal to 5. Check whether all these are positive and integers. Yes, all these are positive and integers. Xj, where j is equal to 1 and 2 are integers. So you have to stop the iterations here. Thank you.